Hey, this is section 5.1, question P4, and we're getting into probability here, randomly choosing two workers to be laid off from a group of workers. So there's 5 out of here. We're going to choose 2 of them. You may remember the formula 5 choose 2 with the kind of parentheses around the 5 and the 2. You could figure out that to figure out how many will be in your sample space. And if you did that, you should come up with 10. But that just tells you the number of ways. It is a nice way to check. When we actually want to list those out, we're basically listing out all the different ways we could choose a pair of workers from those 5. Notice we don't have any that say 28, 28. Because we just had one 28-year-old worker here, it wouldn't make sense to have replacement. In other words, it wouldn't make sense to lay off that same worker twice. So in each of these cases in our sample space, it has 2 separate workers and 10 possible ways to do that. Are they all equally likely? Yes, because it says we randomly choose. Now, if there was some other method of choosing them, it may not be equally likely. Specifically, if there was some kind of injustice going on and we were targeting older workers, then not all of these would be equally likely. So what is the probability that the 2 youngest are the ones laid off? Well, to get the probability here, we want to set up a fraction. The numerator, the top number, should be the number of cases, the number of outcomes in our sample space that satisfy this condition. So in other words, we have to have the 2 youngest people. Well, if we have to have the 28-year-old and we have to have the 35-year-old, there's only one outcome in our sample space that will do that. So the top of our fraction, the numerator, should be a 1. On the bottom, we're looking for all the outcomes in our sample space, so the number of outcomes. So we have 10 of them, so we would have 1 over 10 for our probability, or 0.10. Now again, this is only because they're equally likely. If we had different probabilities for different outcomes, then we can't just do this simple formula of the number of outcomes that are satisfying what we're looking for over the number of total outcomes. But because these are equally likely outcomes, we can do that. What is the probability that the mean age of those laid off is 40 or more? Well, this one takes a little more work. We have to go in here and kind of check the mean. Now, some we can tell really quickly. For example, if neither of them are over 40, we know that the mean's not going to be 40. Or if both of them are over 40, we know that the mean is 40. So we know that this one satisfies it, and we know that these 2 don't. But what about the other 7? Well, we know that the mean is halfway between the 2 numbers because it's not a weighted mean or anything. So just a quick look would tell me that these 2 are both over 40 because they're halfway in between these numbers and the lower number is 39. So I know that all 3 of these have a mean age of 40 or more. 35 to 55, I know the halfway is 45, which is over 40, so that one's okay. Here, it's a little harder to tell, but I noticed that 41 is 6 above this and 6 below this, so this one is also average age 40 or more. This one is not, and I guess I could have counted that right away as not because it's both of them are less than 40. Now, just because I found one that's not doesn't mean the rest will not be. Depends on how we listed them out. So specifically looking at this one, I know that if I go 12 up from 28, I'll get to 40. But from 40, I have to go 15 up to get to 55. In other words, 40 is closer to 28. Another way of saying that is I know that this is going to be over 40. Now, if I didn't estimate that in my head, I would just add these 2 numbers, divide by 2. That's perfectly fine. And this one here, you will get that it's that the mean is less than 40 here. So we have 1, 2, 3, 4, 5, 6 of them that have a mean of at least 40. And again, this is over that same 10 denominator that we used in part C.